All right. So we're starting with MySQL um, training, of course. So this is the training curriculum, right? You would get it in the WhatsApp group. So chapter 1, we'll be talking about understanding databases, database and its structures. We'll talk about inside of that. We'll talk about relational databases. We'll talk about data model. We'll talk about table anatomy and tables that we're going to be using in this course, right? Then that chapter is more of an introduction chapter to introductory chapter to SQL, right? So here we'll be talking about SQL and all that it entails. That's in chapter 2. We'll discuss briefly data query languages. SQL is divided into 5 parts. We'll talk about that, right? Data query language, data manipulation language, data definition language, transaction control, and the data control language, right? And then we'll start picking them one after the other. We'll talk about the data definition language and all that it entails, the data manipulation language and all that it entails in chapter 4. Then the part that is very important to us, right? The data query language and the data query language, which is SQL select statement. And then we'll talk about the remaining part of, I forgot to add them. I'm going to edit this and add to you and send them, right? The transaction control and the data control language. Basically, those are not essentially necessary, but we'll talk about them. I don't want to leave anything out. Then we'll talk about advanced SQL, right? Where we'll talk about Windows functions and CTEs. Right, we'll talk about them. So let's get right into it. Let's get right into it. So we're starting with chapter 1, right? So basically, chapter 1, what is database, right? If you need my attention, please just let me know. I'm juggling multiple screens, right? So just let me know if you need my attention. We have 14 people in class already. Awesome. Please, if you need my attention, just let me know. I hope that every other person can join us soon. All right. All right, so let's continue. Well, all right, so chapter 1, we want to talk about what is databases. All right, so yesterday we talked about SQL and the fact that SQL is very important for analysis, right? What you will discover is that every organization has some information need, right? I mentioned that yesterday that every organization uses SQL, right? Every organization uses a database, right? And database, when people hear the word database, we usually think that it's something very, gigantic, very, very majestic and all that, right? But I put it to you that every single person in this class probably has a form of database that they are working with already at the moment, right? You have stuff like your phone book on your phone, right? You have your phone book on your phone. You have a music library that you use. You have phone numbers on your phones, contact addresses for people. All of those are actually databases, right? So it doesn't have to be something majestic or something gigantic, right? Take, for example, an example of a database is a library that keeps the list of its members, books, due date, and fine. That's a database, right? A company needs to save information about its employees, right? That's a database, right? So when you have tables like employees table, departments table, salaries table, job history table, all of these tables coming together, what you form is a database, right? It could be an online store that stores information about products, orders, customers, branches, and so on, right? All of these are database, right? And if you look at it, what you have inside of data, what you keep inside of a database is data. So data basically is any fact or figure, right? People usually think data is information, right? People say, when you hear people talk about, when you ask them what is data, they say data is information, right? But truth be told, data does not necessarily confer information, right? Data can be anything, right? Your facial expression or your face when you use when you try to when you're trying to use face unlock on your phone, right, is data, right? You did not see anything, right? But it is data, right? when somebody asks you that, do you want to eat shawarma, and you did not respond, the person would interpret your no response, which is silence, as data, right? So data can be a fact or figure. And what that means that is that when the person comes and say, you didn't buy shawarma from me, what do you say to the person? You didn't see anything. And I took that as a no, right? What you have done is that you have taken that data and you have processed it and you have gotten information out of it, right? So what we do, or what we talk about when we talk about data, is the fact that data goes from the fact that you have, and when you process it, right, it then becomes information, right? So informations, right, data can be stored in different form, right? Before now, data were stored in file cabinets and electronic spreadsheets, right? If you attended university, primary school, secondary school in Nigeria, right, you will discover that our teachers have this database called register, where they keep all of our informations as a student in class, right? Then they have this exam sheet, very wide paper like this, where they put all our scores on, and test scores and exam scores, and they total it to let us know how we have performed in the exams at the end of the year, right? That as well is a database, right? If you go to the banks and before technology came in, right, I was privileged to at least go to banks in that time, because my father is a banker, right? So he works with National Bank, right? And we go to the bank and you discover that you cannot get your money like we do right now, right? You have to probably wait for some days to get your money. Of course, I was a baby at that time, and you see that, of course, very few people, right? Having a bank account at that time was actually privileged, right? Very few people own bank account, right? So you can see, but all of that, right, in that time, where they keep your data as in the bank is inside a file. So they open a file for you, they use a marker or something to write the account number on top of it, and that becomes the account details, right? And when you want to withdraw, anytime you save money, right, they write it with pen, and anytime, people are distracting me with. Anytime you save money, they write it, they put it down. Anytime you withdraw, they deduct what you have withdrew, right, and give you a balance and all that. And basically, that is how data or the whole process was a long time ago, right? But now of course, with technology, right, a whole lot of things have changed. So basically, when you say what is data, what is a database? A database is an organized collection of information. A database is an organized collection of information, right? I hope you can see my screen. A database is an organized collection of information. Please let me know if you understood all that I've just said, right? A database is an organized collection of information, right? Having said that, please let me know if you understood, right? So what do we, when we say database, right? How do we manage databases? How do we keep this data, especially in this time when data is popping out at a very crazy speed, right? The speed at which data is being generated nowadays is enormous, right? I read of a research that says that by 2025, right, we'll be generating about 189 petabytes of data yearly, right? And that is each person will probably be generating about 40 terabytes in the world, right? Each person, you and I, will be generating about 40 terabytes of data every year. Are you following me? Right? And that tells you how much of data we generate every day, right? I keep telling people that this class, even though because it is recorded, right, of course, it becomes data now, right? And we have so many of these kind of classes all around the world that are not recorded, right? Google is trying to make sure that everything is recorded, everything can be accounted for, right? And that is what a database is, right? You want to keep every single information. There's so much information that is lost in the air. You've had a whole lot of conversations today that are not recorded. You've probably passed a whole lot of wisdom nuggets, when you are giving advice to people. And this advice, a whole lot of people need this advice somewhere else in the world. But because it's not recorded anywhere, right? It's gone, right? So to manage databases, you need what we call a database management system, a DBMS. You need what we call a DBMS. So basically, what is a DBMS? A DBMS is a program that stores, right? So we pick them one after the other. Stores, retrieve, and modifies what? Data. Right? A DBMS does what? It stores, it retrieves, and it modifies what? Data in a database on what? On request. Are you following me? Right? So when we talk about the DBMS, any software, right? Any software that is able to store data, large amount of data, we're able to retrieve data from this storage. We're able to modify data in that storage. And all of these can be done on request, which means that when I ask for this data, when I query, right? We don't ask now, we say query. Of course, meaning ask. When I query the database, I get a response almost immediately. Then you say that is a DBMS. So there are several DBMSs available in the world today, right? Of them all, right? Number one of them all is Oracle, right? Oracle database. I'm sure you've heard about Oracle database. I'm actually Oracle certified, right? Right. So I'm one of those special people, right? Don't mind me. There's nothing special about it, right? But Oracle is the biggest, or is the biggest database software in the world, the biggest DBMS in the world, followed by MySQL, right? So somebody asked me, I think somebody asked me and said, "Wow, we're using MySQL, right?" Yes, we could have used PostgreSQL, we could have used Microsoft SQL, we could have used some other variant of DBMS, right? But the reason why we are using MySQL, of course, we can't use Oracle, right? Not that we can't use Oracle, I just didn't want to stress it, right? And Oracle is very specific, but MySQL is very popular, right? MySQL is very popular. MySQL runs about 80% of the databases in the world, right? If you look at your organization, some way, somehow, you probably have a MySQL engine running somewhere, right? So it's very popular, right? That's why I chose MySQL for the class, right? But SQL is the same across board, right? So whatever variant of SQL you're using, the syntax are the same. So after Oracle, we have MySQL, then you have Microsoft SQL, we have PostgreSQL, we have MongoDB, we have IBM DB2, we have Redis, we have Elasticsearch, we have SQLite, we have Cassandra, and so on and so forth. All of these are DBMSs. Please let me know if you understood what I just explained. All right, please let me know if you are following me. Hello, please let me know if you are following.
We're following. We're following.
Awesome.
Yes, sir, we are following.
Awesome.
Following, sir.
Awesome. Hold on, just give me 1 minute. I'm trying to. All right. So having said that, right? So what exactly is, so we hear after, of course, we've talked about database administrator, DBMSs now, right? And the people who manage databases are called database administrators, right? So it is not the job of a data analyst to manage the database. I'll say that again. It is not in the job description of a data analyst to manage database, right? The people who manage database for organizations are called database administrator. There's a whole lot of programs on that, right? I am an Oracle database administrator, right? I am also an Oracle autonomous database administrator, right? There are two different technologies, right? Oracle database, Oracle 10G, Oracle 11G, and so on and so forth. I have very good knowledge on them, right? I even have certifications, even though some of them have expired, right? But I have certifications on them. Then I have Oracle Autonomous Database certification. So I qualify to be a database administrator, right? Of course, I'm also a data analyst and I'm also a data scientist, right? So it is the job of data analysts, database administrators to manage databases, right? And what they do is not just to insert data or to store data, they manage the health of a database. So whenever you hear about a database, right, to data analysts, right, or to most people, they don't understand the nitty-gritty that goes into managing a database. A database is like a human being, right? That you have to monitor, you have to manage, right? Imagine almighty Google. Do you know how large that database is, right? And anytime you need to ask any question of Google, right? Have you ever asked Google a question or tried to go to Google and it's not available, right? It is always available. And the reason is because there's so many people, right? Not just database administrators now, so many people, network administrators, system administrators, and the likes, making sure that that server where the database is hosted and the database itself is always available, right? They ensure that there's HA at every time. We call it high availability. They make sure that there's HA at every point in time, that the database is always available. And it's not just for the database to be available. It has to be consistent. It has to have data integrity. It has to be awesome, right? And that is their job, right? So, but they do all of these with SQL. And that is one of the beautiful things about these things, right? SQL is that awesome, right? So, but there are DBMSs and there are DBMSs, right? There are some DBMS, right? Remember yesterday that I said that data can be, I remember saying yesterday that data, hold on 1 minute, all right, okay. All right, good. I said data can be structured. Can you remember? I said data can be structured yesterday, and it can be an unstructured data, right? So data that is generated on Twitter, on Facebook, and all that, they are really not structured data, right? And I said that we have large amount of structured data nowadays than structured data, right? In fact, there's about 80% of structured data, and we have about 20% structured data, right? What that means is that when you say a database is structured, and when you say a database is not structured, so I'm going to call that no structure, right? No structure, right? It means that they are not the same. Are you following me? Structured and not structured, right? It means that the technologies that manages structured database and non-structured database are not the same. Can you hear me? Yes, I can hear you, please. Hello, somebody's trying to call my attention. Hello, can we all hear me, please?
We can hear you.
Yes, we can
Yes, we
hear
can
you.
hear you.
I thought someone was trying to call my attention.
Yes.
Yes.
All right.
Feels you are a bit fast. You are quite fast, but it's good. But maybe person wants to slow down a little.
To slow down. Okay, awesome. Please, right? Just tell me how you want it, right?
Sir.
Okay. Yes.
Sir, that structure and unstructured database is not clear, sir.
Okay, don't worry. You will get it. Don't worry. Just follow me. You'll get it. Right? I'll show you what structured and unstructured database is, right? Structured and unstructured database. I'll show you what they are, what they mean, right? So when we say structured database, right? When we say structured database, basically we are saying that when we say structured database, we're saying that these data are stored in what? In rows and columns. That is basically what we're saying. When you say database is a structured database, right? We say the database is stored in, the data inside of that database is stored in rows and columns, right? And what does that mean? It actually means that the data are stored as what? As tables. Are you following me? The data are stored as what? They are stored as what? As tables, right? Because rows and columns form what? Form tables, right? We all know that, right? Now, when you say a database is not a structured database, right? Imagine, let me paint you a good example of this, right? So that you understand what I'm saying. I might not be able to go deep into no structured database because it's not our focus. Imagine that I'm sure everybody here has been to a library at one point in time, even though we're not in Nigeria, we don't have library culture. But if you are in the university and you want to write exam, you have to go and read in the library, borrow books from the library. When you get to the library, right? I'm going to use my school library as an example. I attended University of Ibadan. So we have this library called Kenneth Dike. Kenneth Dike is the biggest library in the university, right? in Kennedy, if I'm to put a value to the amount of books, please let me mute your mic, please. Let me mute your mic, please. Please help me mute your mic always so that we can have a clean recording. Right? Thank you. All right. So in Kennedy, right? Give or take, maybe we have about, let me just be modest, maybe 50,000 books. Imagine that those books are just piled up, right? So you enter into the library and you just see a large heap of books, a very large heap of books, right? What will you do? Will you be able to get your book and you want to read a book on SQL? Will you be able to get the book? You discover that you will not be able to get the books because you have to go through the pile. It'll probably take you 10 years. It'll probably take you a year to get the book you're looking for. Are you following me? Hence, we say that in that situation, you have that situation is called an heap organized library, right? So what you have most of the time in a non-structured or no structured database is that the data does not have dimension. The data does not have dimension. The data is coming at a very large space and we're just putting everything together. Are you following me? So take, for example, when you post on Twitter, right? What do you post? You post text. In that text, in the middle of the text, you can have emojis, right? In the middle of that as well, you can put a GIF, right? You know those GIF images that flies around now, right? In the middle of that, you can add a video, you can add a song, all in a single post. What you see is like you are cooking rice, and inside of that rice, you have carrots, you have green pea, you have beef, you have liver. You know the way our moms cook this rice, and there's a whole lot of things going on, and that is what you have in that kind of scenario. So when we talk about a no SQL, a non-structured, no structured database, right? Basically, we're saying that this database, right, we cannot put a proper structure to it, right? It means that it is not in rows and columns. Right? These data are not stored in rows and columns. So in that situation, right, let's just say this, right, in so that we understand. When you talk about structured database, we use SQL as what? As the language to what? To communicate with the server that we use to store this data. So SQL is the language to what? To access what? Structured what? Databases. SQL is the language to access what? Structured databases. And we call, for non-structured databases, we call the language, or what we do, no SQL. Right? So we say we have this database is a no SQL database. Right? This SQL is no SQL database. Please just forget that I mentioned this, right? Let's concentrate on structured data and its components. Well, I just wanted to mention to you that there are two types, right? And in the midst of this, of course, you know what technology is, right? In the midst of this, right, there's what we call an hybrid, where you have a situation where an organization is keeping both structured and no structured database, right? And we call that a semi-structured database, where you are working with both, right? When you are employing both, where you're using both, no structured database. Right? So it says relational database management softwares are softwares used to store data in relational manner. Right? So when you hear the word relation, what does that mean? It says relation actually means data stored in rows and columns. Hence tables. Please let me know if you understood that. Right? Relation. So when you hear the word relation, we're talking about tables. When you hear the word relational database, hence, what does that mean? It means that this database management system stores data in form of what? Rows and columns. It's as simple, right? It's as simple. Also, the data in relational database are what? Data relating to each other by nature, right? So when you have an RDBMS, right? When you have a RDBMS, basically, what do you have inside of it? You have the data inside of it connected to each other, right? So basically, what it means is that you have your tables being able to connect to each other. So we'll talk about how that means, and that is where we will be creating a data model, right? So how DBMS are very, very important, right? Because they are what we use to capture or to store database. Right, let's do an introduction to data models. If I'm too fast, please let me know. If you have questions, please, you can feel free to cut me short. This is not it's not a radio class, right? We can have interactions and discussions. Right. So data model. Data models. Right. So data models are fundamental entities used to introduce abstractions in a DBMS. Right. So basically, let us pick these words one after the other. Right. I'm going through these theoretical parts so that we can have a full grasp, and when we start doing the practicals, right, we would not have an issue, right? We'll be able to understand perfectly. So data models are what? Fundamental entities used to what? To introduce abstraction, right? So basically, the word abstraction, what does it mean? When you say abstraction, when you say you're doing abstraction, what does it mean? Abstraction is you trying to form or trying to derive something out of something. You are trying to put together two things to form a single thing. Let me give you an example, right? I don't like to be very abstract, even though we're talking about abstraction. You see what I did there, right? Imagine, right? This is my go-to example of abstraction. Imagine, I'm sure everybody here is used to Nigeria, right? So imagine you are driving at night. You're driving your G-Wagon, and around 10 p.m., you are you're driving over Tomiland Bridge in Lagos. And all of a sudden, at the middle of the bridge, your vehicle stops because there is no fuel anymore. And you're going to Yanoworo, right? Your vehicle stopped. But you know that there's a filling station at Yanoworo. So what you did was lock your car. You took, somebody helped you to the nearest filling station. You got fuel. Then you ran back to your car. But in your car, you do not have a funnel to turn the petrol or the fuel into the car. So what do you do as a Nigerian? Abstraction comes in. You do not have a fuel. You do not have a funnel, and you do not have a nozzle, but you have to turn your fuel into the car. And if you want to say, okay, let me just, find a way to turn it. Remember that some of these cars have a lid on what? They have this iron lid on the surface of, they have this iron lid covering what? Covering the fuel tank, right? So what do? We have to abstract. Abstraction comes into play. Abstraction is that we are looking for a funnel, but we do not have a funnel, so we have to make a funnel. Abstraction basically is saying that, oh, so since I don't have a funnel, I remember that I drank an Eva water in the car. So I can cut that Eva water into two and use the outlet, the mouth part of it as a funnel. What have you done? You've created a funnel. But there's one more thing left. You need something to push down the lid that is covering your fuel tank. Hence, you remember that, oh, you just looked around and you see a tiny long stick, right? And you put your funnel inside at the you put your funnel on the mouth of your fuel tank, and you just put that stick, you just use that stick to push down your to push down that lid, and you're able to turn your fuel in. What have you done? Abstraction. What is abstraction? You've been able to make a funnel from two things that naturally would not relate together. And that is the same thing that we do on a database. Please let me know if you understood that. I need us to understand abstraction before I move on. Please let me know if I need responses now, right? You can unmute yourself to talk. Let us talk about abstraction. Please let me know if you get what I just said.
Not clear enough, sir.
Eh?
Not clear enough.
Not clear enough. Okay, I need responses. I need more responses. I need more responses, please.
You can please do a recap of that, sir.
We. All right. All right, I need responses. I need to know how many people understood what I just said. Please talk to me.
I understand that you need to use your imagination to put things that people and you, even yourself, would ordinarily have thought would not be put to a particular use when you find yourself in certain conditions, certain situations. I understand the you gave as an abstraction. So
awesome. Right? So let's use another example. Abstraction is that you went to a party and you bought drinks, right? You went to Owambe. Nigerians like Owambe, right? You went to an Owambe, right? And I hope you can hear me, right? You went to an Owambe and they served you food, they served you water, right? They served you food, they served you water, right? But it's time to drink wine, and they did not bring a charger, right? I think that's what they call it, those wine glasses, right? The wine glasses, charger, right? They didn't serve you a charger, or they didn't supply a charger, and you want to, you want to take drinks, you want to take alcohol, you want to take some cool drinks, right? So, and you cannot put your mouth on the bottle now because it has to be shared by a few people, right? So you can't color it, right? So what do you do, right? As a Nigerian, what do you do? I need somebody to tell me.
You cut your plastic bottle.
I would have bet. If this was a bet, I would have won. I know you know it. Exactly.
I don't know what you're talking about.
Exactly. That is abstraction. You take that bottle of water, finish the water in it, and cut the bottle into two, right? Such that the lower part of the bottle becomes your cup. Abstraction. Are you following me? Right? You see ladies, I see these
it's like
videos
when you improvise.
Exactly, that's the word.
Material.
Yes, improvise, right? So in databases as well, we do the same thing, right? In data models, we abstract. Abstraction is that I do not want to store all your informations, right? I don't want to store all your informations in my head, right? I know that your name is Awoshika Queen Omoshalewa. You stay in Lagos, you run business, you do all of these things, plenty of information, right? But you are not the only one that I want information about, right? I probably want information, or I'm probably storing information about 100 or 1,000 people, right? So I can't put all your information in my head. So what do I do, right? I can easily give a number to each person. Are you following me? I give a number to each person. I say, Queen is number 1. Alaja is number 2. Mama is number 3. Mr. Femi is number 4. Madam Angela is number 5. Madam Peju is number 6, and so on and so forth. Such that when I say number 1, what happens? The person who is number 1 knows that she's number 1. And basically, what happens is that when you say number 1, it unwraps into our information. It unfolds our information. And that's what we do call abstraction. In data modeling, right, we do not want to cause redundancy on our data, right? Redundancy means repetition of data. You don't want to have duplicates of your data. Hence, we create systems that helps us perform abstraction such that when I want to get the information of Queen and where she works, these informations are on different tables. I can use the system that we have created to link them together such that I can get a full information. Let me give you another example so that you understand this, right? So you are a banker, right? You're a banker. You work with what bank do I like now? What bank is doing well in Nigeria? None. So I'm just going to pick one. Okay, let's use Zenith. Zenith Bank. Hey, don't try to use Zenith Bank in weekend. They will before you hand, right? So let's use Zenith Bank. You work with Zenith Bank. That's advert for Zenith Bank. Okay, that's fine. They will not pay me though. I hope they can pay me if they hear this, right? So you use Zenith Bank, right? You're a staff with Zenith Bank, right? And you stay at Lekki, right? You stay at Lekki. You Your children goes to school at Aja. Your husband works with MTN. You go to church at the mainland, let's say Yaba. Your hospital is at Ikeja, right? And your younger brother stays in Abuja. Your parents stays in Osun State, right? And Nigeria is looking for you, right? Nigeria wants to know who you are. They want to know every single thing about you, right? If you look at it, all these information that I just gave, they are not in one single, they are not domiciled in one single place, because the information about the church is with the church. The information about your children's school is is with their school. The information about your workplace is what? Is with Zenith Bank. The information about every single thing about your husband, about your house, about them, they all reside in different places. But one thing is common. One thing can help us tie these things together. One thing can help us tie what? These informations together. What is that? Who can guess? NIN. Are you following me? Your NIN. Right? So what it means is that if I connect all the tables together and I search for a particular NIN, it will link all the tables. We call it piping, right? In our program, we call it piping. You will pipe all the data across each other, right? You will join it. In SQL, we call it join. You join all the tables together such that with one single lookup value, you can get all the other words. You can get all the other value. And that's what we call abstraction. Are you following me? So instead of having all of your data in a single sheet where it becomes cumbersome, we can link multiple tables together, right, through a system called constraint. We talk about it, right? That can help us what? Normalize the table, normalization. Please I need, just raise up your hand if you understand that concept. Just give me a hand raise if you understand that concept. If you understand, at least to an extent, right? Just give me a show of hand. Just give me a show of hand. Just give me a show of hand if you understand that concept. Waiting, I'm waiting, I'm waiting. If you do not understand, let me know. Just omit yourself and let me know. Eight people say they understand. 8 people. I need more participants. Let me know. Awesome. Madam Udwak, are you there? Madam Angela, Sammy, Iceman, Biola.
I am here.
Do you understand?
Yes, sir.
Yes, please, if you understand, like I said, just give a raise of hand so that we can move on. All right, Madam Udwak, do you understand? Sammy,
yes,
do you understand? Awesome. I want to believe we all understood that concept. Right? If you have questions, you can ask me, or you can drop your questions on the chat box on the chat, using the chat, right? Or you can even drop it on WhatsApp as well, right? You can put your chats here. All right. Go to continue.
So the chat is not open to everyone.
Oh, sorry, the chat is not open to everyone. Yes,
the chat is not enabled.
Sorry, let's use WhatsApp.
But the chat isn't open to everyone.
Yes, because we're not using the full version. We're not paying for it. Awesome. All right, let's continue. I think everybody is on the same page now, right? If you are not telling me you don't understand, it means you're on the same page as us. All right. So DBMS, data model defines how data is connected to each other and how they are processed and stored inside the system, right? It's as simple as that, right? Data models, define how what data is connected to each other. Remember, I talked about using a single value to find out values across multiple sources, right? And basically, that's what the data model does, right? You can do data modeling in R. You can do, in SQL. Why do I say R? You can do data modeling in SQL. You can do it in Excel. You can do it in PowerBI, and so on and so forth, right? It's a very common concept because it helps us manage our database better, right? The most popular data model in DBMS is the relational model, right? We'll talk more about the relational model as we proceed, but let's just look at the main highlights, right? Data is stored in tables called what? Relation. We talked about this already, right? Relations can be what? Normalized, right? We'll talk about normalization using what? Using constraints, right? Normalizing means that you are not duplicating your values. There's no redundancy, right? And you are using a particular system. We call it system constraint. I mentioned that earlier, right? To normalize the table, right? Each rows in a relation contains what? A unique value, which means that because we do not want to what? Because we are normalizing our table, right? We are saying that each row, a row uniquely identifies a person. So in this class now, right, I cannot duplicate Queen's information. If I duplicate Queen's information in my database, right, it means that my database is not consistent. The database is not normalized. Because what it means is that if I do that and I ask for and I run a query, it means Queen is going to appear twice, right? And if it is the same person, if it's the same data that is appearing twice, then there's no consistency, right? That is redundancy, right? But you want in Nigeria, take for example, BVN. In Nigeria, NIN, we have a duplicate of that, right? In America, I know they do social security number. In UK, I think it's BRD, British residential biometric or something. Right? Every of these countries have this unique value that uniquely identifies their citizens. No two citizens can have the same identification number. And when we're in university, no two persons can have the same matric number. No two persons should even have the same phone number in an ideal environment. Although there's basically you cannot go to MTN and register a number with for two different people. Although in Nigeria, things are a bit, let's leave that one, right? But I hope you understand the concept. So each row must uniquely identify a unique value. Must identify a unique value. We'll look at it as we proceed. Each column in a relation contains value from the same domain, right? So basically, if I have in a situation, let's say I have a table, right? I have, hold on. Sorry. All right. So let's say I have this table. Right? And I have here these columns. So this is a table, rows and columns, right? So if you have not seen a table before, this is what the table looks like. Right. So we say what we have here is ID. What we have here is first name. I'm sure everybody in this class should know this, right? Okay, maybe one person. Last name and age. Let's use age. Right. Right? So what does that mean? It means that this ID column, if I put one here, can I put Ade here? Is this right? I need somebody to tell me. Ade, then I have 3. Is this right? Hello?
No, sir, it's not right.
Why? Why is it not right?
That column is for number.
Value.
I think one is lookup value and fact value, that you can't put everything together. It should be separate.
Okay, see point moving stuff. Oshe lecturer. Oshe lecturer. Right? Let me say Queen Drake. Let's give you Sunday. right? So basically, right, the reason why they cannot be together, even though we all got it, is that this column must have the data in it must have the same data type. So in this situation, if this column is a numeric data type, is a numeric column, right? If it's a numeric column, then having character here is wrong. If this column is a character data type column, then having one here is wrong. Are you following me? So these are one of the things that we do that we try to ensure with what? With the data model concept. And you will discover that this is what we call a messy data. When you say data is messy, right? These are one of the things that you find in messy data, where a column is not a data type are not specified for a particular column. Hence, you see data, different types of data in a single column. A column that is supposed to be character column, you see numbers, you see date, and all of that. And those kind of data, right? They are difficult to maintain or to manage and analyze. But it is the job of an analyst to be able to clean up those kind of data. Hence, we say that data analysts spend this kind of data is what causes a data analyst to spend 70% of their time cleaning data. Are you following? Right? So, relational model. We're still talking about relational model. Right? So, in the relational model, somebody was calling me. All right, so we can continue. Good. Right. So, in the relational model, right, we have what we call the entity relationship model, right? The entity relationship model. Entity relationship model is based on the notion of real-world entities and relationship amongst them. ER model is best conceptualized, is best used to conceptualize design of a database, right? Even though you are data analyst, right? I'm just trying to make sure that we understand the database concept, right? Before we jump into having to use SQL, right? So take, for example, what business can we run? Let's say that we have a school. Let's say we have a school, right? Let's say that we have a school. The name of our school is Avita, right? And Avita is a school that wants to change the world, right? So in Avita, right, what we teach is technology, right? We teach technology, we help people become better and get opportunities, right? What is very paramount or important to Avita, right? We want to know what are those things, right? Students are what is paramount to what? To Avita, right? Students. They are very important to us, right? Everybody here is very, very important to me. Your success, oh, that's what I want, right? Students, lecturers, right? That's another very important thing to us, right? We have lecturers. I'm not usually the only one that teaches here, right? I usually hire people to teach as well sometimes, especially for the technologies that I'm not very vast in, right? Or technologies that I don't have interest in, right? So we have lecturers, right? Lecturers is another, right? Courses, yes, we teach different courses, right? We teach different courses. Ma?
I can't see the screen.
Hey, the screen is on. Oh.
Okay.
Can we see the screen?
Yes, I've seen it now. I'm seeing it.
All right. Right, student lecturer courses, right? Let us leave it at this, right? Courses, right? So we have this, we have this, right? These things, these three things.
I can't see it though. I can see what is written before, but mine is not showing.
Hey. If you cannot, can we see the screen, please? Let me know if you can see the screen. Let me know if you can see my screen. If you can see my screen, just raise up your hand. Just raise your hand.
Yes, I can see it now. I can see.
I can see it.
All right. All right. So when you can't see the screen, sometimes it's a network issue. Probably be your network or my network, right? Just give it some time, right? It will load up. Are you following me? Right? Sometimes it might just be a lag in network, right? Good. So just give it time, right? So in real life scenarios, right, when you talk about businesses, organizations, right, they tend to itemize their real world data points. The real world data points are called entities, right? Real world data points are called what? Entities. Real world data points are called what? Entities. So we say entity. An entity in a ER diagram or ER model is a real world what? Data point, a point of interest, a subject of interest, right? right? We call them what? Entities, right? Entities in an ER diagram are usually in what? In square shape, right? Like you see them here, they are usually in what? In square shape like this, right? Entities. Can you see? Entities, right? Attributes, right? I'm moving. Attributes, these are properties of entities, right? Remember in secondary school, they taught us that the attributes or the properties, the characteristics of a living thing is Mr. Nainjadi, right? How many of us remember? If you don't remember, let's go back to school to go and collect the school fees, right? So attributes are properties of an entity. They are characteristics of an entity. They are the features of an entity, right? So take, for example, if we say student, what are the features of student? It says every attribute is defined by its set of what? Values called domain. For example, in a school database, a student is considered as an what? As an entity, right? A student that is considered as an entity must have attributes like what? Like name, age, and class, right? So, of course, my NIT students have done this before, right? Where we broke down what? Where we broke down entities into what? Into their different what types of what? Attributes. So when you talk about attributes are usually the characteristics, the attributes, the properties, the features of an entity, right? So if we say lecturers must have an ID, lecturers must have name, they must have gender, they must have date of birth, they must have state of origin, they must have the course that they are teaching, right? They must have a department that they belong to, they must have a house address, they must have a office number, they must have a faculty that they are assigned to, and so on and so forth, right? If you look at it, a citizen of Nigeria, what are the things that a citizen must have? I need you to throw me just one features, everybody, one features that one attribute that you think a citizen of Nigeria should have, right? So that we can use that to wrap up this point about attributes. Everybody, let's go. Let's go. Awesome.
NIN.
Every citizen must have an NIN. Okay. State of origin. Awesome. State of origin. Awesome.
An international passport.
They must have
international passport.
Local government.
Phone number.
An international passport.
Name.
BVN. Biola, not every. Hold on, everyone. Biola, let me correct that. Not every age, yes. Not every Nigerian, not every citizen has an international passport. You know, you can be in the country and not travel out ever till you die. And if you are not traveling out, you don't need an international passport.
Does not have.
Yes, so I said what they should have, not what they have.
In terms of attributes, I'm talking, of course, in terms of context, right? In terms of attributes.
So
right?
you said what they should have, not what they have.
Yeah, you will have a gender.
They would have gender. Viola, what yourself. Right? They have gender. They have residential address. Right? They have. You want to know if they are employed, self-employed, or unemployed. Phone number, yes. Exactly. You want to know if they are dependent or independent. Do you understand? You want to know if they are, what else? All of those things are attributes of a citizen, right? So basically, that is how we develop what? That's how we. So what does this mean? These attributes are what forms your table. They form the columns of your table. These attributes form the columns of the table. So if you take an example of a unique person like Biola, I want to say Biola's surname is Biola Oladoku, is male, is born on this so date, he stays in this address, his parents' name is this, is all of those kind of things, right? We can use that word to get his phone number is this, and so on and so forth. His email address is this, right? He's from this state. He's from this, the state of origin is this. He resides in this state, right? This is what he does. He's employed. This is where all of those kind of informations, right? They would what? They will make up the data, the attributes make up the data for each of what? Each of our observations on rows. Now, lastly, on ER diagram, right? Relationships. Relationships are logical associations among entities, right? Relationships are logical associations among entities. Relationships are mapped with entities in various ways, right? So take, for example, if we say student is an entity, and courses is an entity, right? What will be the relationship between a student and course? Right? Let me give you an example. Right? If we say relationship between student and course, right? Every student must undertake at least one course. You cannot be a student without taking a course. Are you following me? So what qualifies you to being a student is that you are undergoing or you are undertaking a course, right? So the relationship there is that every student must undertake. Undertake is the relationship between what? Student and course. The relationship between what? Between lecturers and courses is that every lecturer must teach. Lecturers teaches a course. Teaches there is the relationship. That is how we link tables together. Every student must be assigned to a lecturer. Every student must be taught by a lecturer. Can you see? So those are relationships. Relationships is what helps us join two tables together. Hence, when you join the tables together, what do you have? You will have a data model, right? You have a data model, right? We'll talk more about that later in practical now. And also we'll talk more about it when we get to Power BI, right? Let us continue. Also, we want to look at the anatomy of the table, right? If you go by our curriculum, right? We've talked about relational databases, we've talked about data model, we're talking about anatomy, and we'll talk about tables. We'll finish chapter 1 and chapter 2 today, don't worry, right? Then tomorrow, next class, we will start SQL in full, where we start writing codes and all that. But let's get this part. These two chapters are just theoretical, right? Let's get them off the road. Let's get them off our neck, right? So let's go back to our slide. If you have questions, please do not hesitate to drop your questions. Do not hesitate to drop your questions. All right, anatomy of a table, right? Let's look at anatomy of a table, relational database terminologies, right? I hope we can see my screen. So what is a table, right? We've been talking about the table, right? What is a table? A table is the basic storage in storage structure of an RDBMS. A table is a basic storage structure of an RDBMS. Let me show you something, right? Let's even try some things, right? I hope you can see my SQL. Please let me know if you can see my screen. Yes.
SQL is the storage structure of what? Of an algorithm? Did you?
No. RDBMS. Let me go back to my slide so that you can see. Right? A table is the basic storage structure of a RDBMS, right? Of a database, basically. That's what we're trying to say there.
Okay. Thank you. I'm sorry.
Awesome. No, it's fine. It's fine. All right. So basically, let's see. Let me show you something. All right. Let me show you something. Downloads. HR. I told you to download an HR script from when we started, right? Let's look at what the script entails, right? So this is what will be, by the end of this program, everybody will be doing a project that looks like this, right? We'll be creating your capstone project is to create a database, right? An example of what I have here is a database. Can you see? This is SQL statement to create a database, right? SQL statement to create a database, right? So remember, I was talking about a table is what? Is the basic what? Is the basic structure of what? Of a database. A table is the basic structure of a database, of an RDBMS, right? Of a database, right? And in this place, I'm trying to create a table. But before I create the table, I want to create a schema, right? I want to create a schema. Let me run all of this. All right, what I have done, I hope you can see my screen. I want everybody to reply. I hope you can see my screen, right? What I have done just now is to create a database.
Yes.
Yes, I created a database. and I filled the database with data, and I have created I've created data models, and everything is awesome. Let me show you. Let's reverse engineer this database. Let's reverse engineer this database so that I can show you, since we're talking about data model, let me show you. I don't want these ideas to be abstract, right? I want us to get it and get it right. I want us to get it and get it right. You'll be able to do all of this very soon, don't worry. Just follow me. Save to vote. Next. Next. So I ran that script to create a database, right? To create a database. The database is called HR, right? And I want to show you what a data model looks like, what the data model looks like. Right, can you see? Can you see? This is my data model. Right, this is my data model. Right, if you look at it, in this database, the database is called HR. I have 7 tables. I have a table called locations. I have a table called countries. I have a table called departments. I have a table called regions. I have a table called employees. I have a table called jobs. I have a table called job history. And I have a table called, yeah, I think that's all. That's all of it, right? If you look at it, these tables are all connected to each other. True or false?
True.
These tables are what? They are all connected to each other. This is what we call a data model. Are you following? This is what we call a data model, such that if you look at it, I can get information from all of these tables just by what? Understanding. If I understand the way these tables are linked to each other, I can use them to fetch information from employees tables to join what? The job history table. The job history table linking to what? To the departments table. The department table linking to what? To the what? To the locations table. The locations table is linking to what? To the countries table, which links to what? To the region table. So from this alone, I can get information from about 6 tables or the 7 tables at the same time, or all at once. And this is what we call a data model. Yes.
Hello.
Yes, I can hear you.
I can't see the table.
Can you see my? You're just hold on. It will pop up for you. Your network is a bit slow. That's what it means.
Okay.
Yeah.
Okay.
Images. Voice travels faster than images. It will load up. Don't worry. Don't worry. Can you see? Just raise your hand up when you can see it so that we know that we're on the same page. All right. So this is what we call a data model. Mr. Femi, are you still there?
I can see it now.
Awesome. I told you.
Yes, sir. I'm
Mr.
here.
Femi still here? Awesome. Awesome. Solomon, I see your hand raised.
No, it's a mistake. It's a mistake.
All right. All right. So this is what we call a data model. At the end of this program, in 4 weeks' time, glory to God, in 4 weeks' time, you'll be able to develop something like this. Right? You'll be able to develop something awesome like this, right? So this is what we call a data model, right? In this situation, all the tables are linked to each other, right? So let me go back to my, right? So if I I just want to give you a taste of what we're trying to do, right? So if I say, give me a minute. Save. All right. So if I say use HR, we talked about your database fetching data, using SQL to fetch data from the database. So if I say select, all. I'm sure that a few people here actually understand. They know SQL. They're my organs. They are here, right? Select all from employees, right? From employees. If I run this statement now, what happens? This statement connects to the database and fetches what me a result. Can you see the results? Can you see that it's in a table form or it's in a tabular form? Can you see? I hope you can see.
Wow,
right?
wow.
This is
Yes.
what? This is information inside. These are employees' information, right?
Wow.
So what do you see? Are you following me?
Yes.
Hello,
We
are you
can't
following
see.
me?
Oh.
We see the whole table.
Can see.
Okay, we can see now. I can see it now.
All right, all right. So what is the entity here? Who can tell me? What is the entity in this statement? Remember that we say entity is a what? Is a subject matter, right? A data point of interest. So what is the entity in this statement that I just ran?
Employees.
Sammy, I can't see you.
Employees. Employees. Abiola, give it time to show up. Your
Sir,
network
I
is slow.
cannot see.
You will see. Don't worry. You will see. Deliverance comes to you. You will see.
Put on your glasses, please. You're gonna see.
Can you see now? Can you see now? Can you see now? All right. So I'm just going to continue. I believe everybody can see, right? So employees is the entity.
Yes, sir, I can see. I think I'm having delay.
Yes, it's just a delay. Don't worry. Right? So employees is what? Is the entity, right? And if you look at it, employee ID, first name, last name, email address, phone number, hire date, job ID, salary, commission percentage, manager ID, and department ID are what? What are these? What are those? Who can tell me? Sammy, what are those?
Attributes.
Attributes.
Yeah, attributes.
Attributes. Awesome.
Attributes.
You see? Yeah. You guys are good already. We can end the class. You can go and start looking for opportunities. You know SQL. Right? So what we have now is that you have an entity, and these are the attributes of that entity. Let's try another entity, right? So that you understand what we're saying here, right? And get a full graph. So if I say select asterisk, that's asterisk means all. We'll talk about it much later. From departments, right? Remember I told you that what attributes, entities are data points that are peculiar to what? To a organization or a business or whatever. So this business that we have, this HR is the business, human resource, that's what it means, right? They are peculiar or they are particular about what? Employees, they're particular about department. So what does this department contains? Right? Can you see? So you see that in this department, we have departments, department ID, department name, manager ID, and location ID. Look at it. It says department 10. Department 10 is administrations. The manager is 200. The location ID is what? 1,700. Does this make sense?
Serious sense.
It makes sense, right? This person is a genius.
It makes sense. It makes sense.
It makes sense. So you understand what? So if you say, of course, we know that. So department ID is what? So we say if we say that what is, so if I ask you what is, go to department 10, you know what to do, right? You know that department 10 is administration, right? Or go and call me the manager of department 10, right? You know that department 10 is administration and is in locations 1,700. But what you do not know is who is the manager. We just know that the manager is what? 200. And the location is what? 1,700. So how do we get more information? Even though you people say it makes sense, right? It does not make sense entirely, because at the moment we don't know who 200 is, and we do not know what 1,700 is. But what we know is that these values can point us to what? To the information we need. If we come back to employees details that we ran earlier, right? If we run these employees again, right? And we go and look for who is what? Who is employees what? 200, right? We'll go down and we see that, oh, so the manager of department 10, can you see that she's in department? Look at it. Let me select everything. Look at it. Right? Can you see that this person is in department 10? Can you see? Which is administration, what? Administration department. So the manager of department 10 is Jennifer Wayland or Wayland, right? Whose email address is J Wayland. Our no phone number is that. Our date of birth is this. This is her job description. This is her salary. She does not receive commission percentage. And she also has a manager that is what? 101. So who is our manager? Let's go and see our manager. Our manager is 101. Nina Kocha. Can you see? But Nina Kocha's manager is what? Is 100. Can you see? His employees 100. Can you see? Who is what? Stephen King. Stephen King does not have a manager. Can you see? He's the Okapakota of them all. He's the CEO. He's the MD. Can you see that he does not have a manager? So if you look at it, some way, somehow, these two tables are linked to each other. So for us to get more information, so if we come back to employees tables, right, and we say, okay, so what is this person? Alessandra Arnold, right, is in what? Is in department 60. What department is that? Department 60. What do? We use this value 60 to go into the departments table to go and get more information about it, right? Such that we'll say that, oh, 60 is in IT department. Hence, right? If I want to say, let me show you something. Remember we talked about abstraction, right? This is just a general from select all from employees. Okay, let us say select all. Select first, select employee ID. Just follow me. Just follow me. You will write queries, you will tire. Just follow me. All right, let me run this statement so that you see. All right, look at it. Look at it here. So, what did I do? What did I do? I want you to pay attention. I want you to pay attention to what we did here. You will write statements like this very soon, right? I'm just trying to explain this first chapter to us so that we understand it very, very well, right? Remember we talked about data models helping us what? Enforcing or helping us with abstraction. Data model making us perform abstraction, right? What I did there is abstraction. Select employee ID first name, last, and sorry, before I go forward, right, before I explain this, I forgot to mention, if you understand English language, are you following me? If you understand English language and you understand how to reason, right? You understand basic reasoning, right? You know SQL about 40-50%, right? And I'll show you. Like I said, I'll say it again. If you understand English language and you know logic, right? If you can put one or two together, right? You understand SQL about 40 to 45-50% of SQL already, right? Because SQL is actually English language, right? We use English to interpret our logic, and that's what we do. So look at it. Select. Who does not know what select does? Select is to select something. You are selecting something from something, right? Select employee ID, first name, last name, department ID, department name. From employees joins department using department ID, right? Where first name equals Alexander. What did I do? Let us go back to this table, right? If you look at the employees table, let's go back to the employees table. If you look at the employees table, we do not have what? Look at my select statement, right? I'm just showing you so that you have something to think about, right? Look at it. The employee's ID is this here, that's the employee's ID. This is the first name. Can you see first name? Salary is here. Can you see? Salary is coming from here. Department ID is also present here. Are you following me? But department name is not here because this is the end of the table, right? Can you see? Department name is not here. So where did we get the department name? Let's select the department what? Let's select the department, right? Look at it. This is the department table. You see that department ID is here again. We saw it in the employees table. We saw it here. And this is what? This is the department name. Are you following? So it means that this name here, this department name is coming from this table. Hence, the reason why we are joining the two tables together. So that we can get what? The full information that we need, right? So you see that we're saying that, okay, so all of this is coming from the employees table, right? This one is coming from what? From the department table. This one is common to both of them. This table, this column is common to both of them. So it means that if I need the department name, then I must what? Be able to join the employees table to what? To the department's table. But what am I using to join them? What is common to both of them? The department ID. And I'm restricting to say, okay, I don't want to see all of it. I just want to see for what? For the people who are called what? Alexander, right? If we run this statement now, you'll see that it returns just what? Information of what? Of just two persons who are Alexandra, right? Employees ID 103, Alexander. His salary is what? Is 9,000. Is in department 60, which is IT department. And we have employee ID 115, who is Alexander again, who receives what? 3,100, is in department 30, which is what? Which is a purchasing, right? So you see abstraction. We used what we have to get what we want. Does that make sense? Does that make sense? I don't expect it to make full sense, right? But just use this concept to understand the data model, right? Remember that I said in data model, we are what? Fetching data. We're able to fetch what? Link our tables together to be able to fetch data from multiple tables at the same time, right? Or get queries from two or more tables at the same time. This is what we have done here. Please give me a feedback if this makes sense, right? If this makes sense before we continue. Feedback, people. Don't be tired. Don't be tired. We're just starting. We're just starting, right? You should be excited about the possibility that you're going to start writing statements like this, right? Feedbacks. Do we understand it? Please let me know. Do you understand it?
It's okay, sir.
Awesome. If you are lost, please let us know.
Right on, sir.
I should write on. Awesome. Who does not want me to write on? Who wants to hold my card down? All right, I believe we all understand. Talk to me.
I want you to throw more light on that.
Okay, I should throw more light on what? On what part?
That departmental ID.
All right.
Yeah. Just explain
Okay.
more on that table, please. Let me.
All right, Sammy, talk to me.
Yeah, I wanted to ask similar question. The department name and ID.
All right. Right. So if you look at it, right, what I did not explain, and the reason why I did not explain is because we've not gotten there. What I did not explain is that this department name, remember, is present to both tables, right? It's present in the employees table, right? It's present in the employees table. Look at it here, right? It's present in the what? In the department table as well. But look at the department table. If you look at it, the values in this table are not duplicated. Can you pay attention to that? They are not duplicated. You see 10, just 110, 120, 130, one, all of that, one of each, which means that this column uniquely identifies each what department. So no two departments can have what can be department 10. No two department can be what department 20. Right? But if you come to this table, you will see that department 90 is duplicated. Can you see 3 of them? Can you see department 6? Right? Duplicated. Can you see what? Department 100, duplicated. Right? Can you see department 30? Duplicated. So what exact department 50? Duplicated. So why? Why is that? Why are they duplicated? Right? It tells you that there's a relationship between the employees table and the department table. And the relationship is that every employee must belong to a department. Every employee must belong to a department. Look at the number of departments that we have. We have 27 departments. Can you see? It says 27 rows returned. We'll talk about that much later, right? So what that means is that in this department, in the departments table, we have what? 27 departments in the company. 27 departments in the company, right? That's what we have. But if you look at it, how many employees do we have? We have 107 employees. Can you see? 107 employees, because each employee is unique, right? Their values is unique. Their value is not duplicated. What does that mean? It means that these 107 employees are what? Are in what? This 27 department is shared across what? Across these 107 employees. Hence, 2 people, 3 people are present in the department. 5 people, 20 people are present in one what? In one department. Right? So the relationship between them is why we are able to what? Why we are able to join them together. If not because of this department ID, we will not be able to join the department table and the employees table together. I'm taking this too deep. Let us take it one step at a time. I'm going to retract from explaining this going forward, right? Because we've not even gotten to this part that I'm explaining. You're already talking about joinings and all of that. I just wanted to show you, what's it called? I just wanted to show you abstraction, right? Let's take it one step at a time. You would understand it as we proceed, right? But just everything I've said, just hold it, right? Even if it doesn't sync well, just hold it, right? So let's go back to our slide. All right, anatomy, table anatomy, right? So we say a table is the basic storage structure of a RDBMS, right? So let's look at this image. We have we have label 1, right? It says this label, what you have there is that is a what? Is a row, is a single row or tuple. A single row or tuple. What does this do? It says this represents all the data required for a particular employee. Right? If we go back to our employees table, can you see? This is the information of all the information about the employees that we have on the employees table. And it is unique for that person. Right? So this is a row or a tuple. Remember, we said that what? The row or a row must uniquely identify or must be unique for each what? For each observation, right? So each employee, each student must have a single row that is unique to them, right? That is what you have in the first what? In the first. So you have a single row, right? You have a single row. That's what? That represents all the data required for a particular employee. Each row in a table should be identified by a primary key, which permits no duplication. We'll talk about primary key and its duplication act much later, right? What's the second one? Number 2, right? It says column or attribute. We know this already. Column or attribute, right? It says this column is a primary key column because it contains employee what? Employee number. Now, what does this mean? Even though we have multiple columns here, employee's ID is a column, first name is a column, last name is a column, salary is a column, commission percentage is a column, department ID is a column. But why is this column very important? This first column. It is the column that is the primary key column. What does that mean? It's the column that contains the values that uniquely identifies each of our employees. The primary key column uniquely identifies each observation, each row in your data, in your database. Are you following me? It's uniquely identified. That's why we call it a primary key column. We'll explain more about that when we get to it, when we get to constraints, right? So this column is not the same as all of this column. This column, no duplication can happen inside of it. That's the essence of a primary key. No duplication can happen inside of it. But you can see 2 people, right? If you look at our result here, you can see that 2 people, let's run this again, right? 2 people who bears the same first name. In fact, 2 people can have the same salary. 2 people can be in the same department, but the 2 of them cannot have the same employee ID because this column is a primary key column. Are you following me? Are you following me? Right? Then we have the third one, which is what? A column that is not a key column, right? Like we just mentioned, right? This is a key column. The employee table, the employee ID is a key column. The other columns are not key columns. What does that mean? It means that the values can be duplicated in those columns. But in the employee column, employee ID column, in the matric number column, in the NIN column, in the BVN column, even in the account number column, these columns cannot, the value inside of them cannot be duplicated. Hence, they are a key column, primary key column, right? Awesome. What's the third one, right? So we said this column. So all of these other columns are what? Are non-key columns. They are not a key columns, right? Then we have a what? We have a foreign key column, right? It says this column contains data that defines how a table relates to another table, hence the word foreign. We'll talk about that later, right? And what that means is that this column, this primary key column, I showed you earlier, right? Even though it's duplicated there, naturally does not belong to this table. It comes from another table. We'll talk about that later. Just know that we have what we call a primary key column and a foreign key column. Then we have what? 5. 5 is what? Is a what? Is a field. It is a field is an intersection of what? Of a column or row. It can only take what? One value. Field. This is also called cell, right? Remember in Excel we call this cell, right? It's also called field because it contains one single value. And when you have a field that does not contain a value, we call that what? A null what? A null field value. A null value field, sorry, a null value field, right? That is this, even though you can see null inside of it, there is no value inside of it, right? Let's look at this. Let's add salary. Let's extend this a little bit to see if all right, look at it. What does this mean? So this value, this field is a field that contains a value. This field does not contain a value, even though you see null there. That null is not there. It's just showing you that these places are empty. What does it mean? It means these 2 people does not what? They do not receive what? Commission percentage. So you can have a field column, or you can have a field that contains what? Values, like all these ones, right? They contain value. There are fields that contain value, and you can have fields that does not what? Contain value, right? Basically, what we have just gone through is the anatomy of a table. So in your table, You're looking for primary key columns. You're looking for foreign key columns. You're looking for columns that have what field and columns that do not, I mean, fields that have value and fields that do not have value. Please let me know if you understood that. Right? Let me know if you understood that. I'm going to ask us in our next class. Right? I'm going to ask us in our next class. Let me know if you understood that before we proceed.
Please, sir, can we just
I get it now.
Keep this the thing for us so we can see it and we can write. Thank you.
What's that, man? I didn't get that one.
That is this table anatomy, the various terminologies. As you were talking, I was noting, but I haven't written, so I want to just be able to take a few things down, please. Because I can see the database.
Can you see it now?
Yes, so
All right, so I'm just going to leave it for a few minutes so that
you can share this slide with us?
What I normally do, I just snapped it so that it will make it easier for me. You can snap.
Also,
so
you can just snap it, then later you jot it down.
I will share the slide with us, but not now.
Okay, sir.
Yeah, because if I share the slide, you will not come to class.
No,
Sir, please, will you send us this document?
Yes, I will send it, but not now. You would have it, but not now.
So maybe you should give us the one that we do in the class immediately after class.
I should do what?
Like maybe you can just set the one that we, like the class that we just did. So just send the slide class.
Not every. I want to scan.
Okay, that's a good idea.
All right, I'll drop the slide with. I'll drop the slide for you. Don't worry. I'll drop it after class.
All right, thank you. How long has this been going on? For a while.
Please let me mute your mic. Thank you. Can I continue? Please let me know if I can scroll down, if I can continue now. We have.
Since you said you will give it to us, please continue, sir.
All right.
Thank you.
All right. Yes.
Thank you.
So you can continue.
So,
thank you, sir.
All right.
Yes.
Let's look at MySQL as a database management system, right? Let's go back to where we are, right? So we'll talk about all of these, the tables in this course. But before we talk about tables in this course, let's look at MySQL as a right? Let's look at MySQL as a database management system, right? Awesome. Right. So if you see, right, this is this interface that is an image of the interface that you have here. Can you see this interface, right? Like every other interface or every other application, right? You have your menu bars. Can you see the file, the edit, the view, query, database, server tool, scripting, and help? They are all menus, and each of these menus contain they contain related functions or related group of functions, right? So if you want to do anything about query, you would use the query function or use query tab. If you want to do anything about the database, you use what? You use the database tab, server tabs, and all of that, right? We have on here, right? MySQL allows you to have multiple scripts opened, right? You can have multiple scripts open. Like I have this script and I have another script. I can have multiple scripts opened. Right. Then we have the work interface. This is our workbench. This is where our worksheet. This is where basically it's called the editor actually, like in R. Remember, right? Like this is our editor here, right? And this is where we see our results. This is the where our results comes out. This is where we get description of our outcome or of our output, action outputs. Right? You see your action output from here. And on this side, we see what we call a schema. Can you see my cursor? Right, you see what we call a schema, right? A schema. We'll talk about what a schema is in a few minutes, right? Then we have what administrations. If you want to perform administrative tasks on MySQL, this course does not, I'll say this, this course does not cover administrative tasks because you are data analyst, and this course is not database administration. So, right? So this program does not cover the administrative part of MySQL, right? It is the job of a data analyst, right? So here you have your schemas. Can you see this HR schema that we created earlier, right? This is what we call a schema, right? A schema is a database, right? A schema is a database. Let us look at that in the slide, right? So before we go to schemas, let's look at MySQL is a database management system that allows you to manage relational databases, right? So in the schema, we can have multiple databases, right? Can you see we have CC here? This is a database. Can you see that's the structure of like a drum structure? Can you see? That's a database. This is another database. If I create, let me create another one. If I create another database, if I say create database, Avita, right? Right? Can you see in my output? What do you see? Create database. One row was affected. It tells me that, can you see that green tick? When you see this green tick, it means that that statement ran successfully. When you see the red tick, can you see the red tick here? It means that there's an error. It will give you an error, right? It means that's an error, right? So it means that this query or this statement ran successfully, and it says one row affected. If I reload my schema, can you see? Now I have another database called Avita. Are you following me? I have another database called what? Called Avita. If I create another one, right? Let's call this Zenith, right? Since we've used Zenith in the example, right? Can you see? Successful, right? The green tick, it tells me what I did, the action that I did, create database, and it tells me what one row affected. If I reload my schema, can you see Zenith? Right, Zenith. Right. So what does that mean? In this part, right, you can have multiple databases. Right now, I have four schemas. We call them schemas, even though they are databases. We call them schemas, smaller portions of databases, right? Schemas. Now, all of these together forms what? Forms a database, right? But this database does not necessarily have to link together because HR can be totally different from Avita. Avita can be totally different from SYS. SYS can be totally different from what's called Zenith. But the MySQL interface allows you to manage multiple databases, right? So each of them are databases, right? And this system, from this system, you can manage multiple databases at the same time, right? From if I want to use Zenith now, even though I'm using HR before, I just say use what? Use Zenith, right? Basically, it's like saying activate Zenith so that we can what? We can run query against it, right? If I run that, if you see that, can you see Zenith popped up, even though there's no table inside of it at the moment, right? If I want to use Avita, all I just need to do is say use Avita, and it will what? It will pop up. Zenith what? Will contrast, and that will pop up. Can you see? Okay, Zenith didn't contract, but now if you look at it, Avita is what is active, right? Avita is what is active. Zenith is no longer active. HR is no longer active. So you can switch between schemas. You can switch between databases. So MySQL allows us what? Allows us or affords us the ability to be able to work with what? Multiple databases at the same time. It says it is an open source software backed by Oracle, right? Oracle actually manages it. Hence, the reason why we say Oracle is one of the biggest. It's actually the biggest database company in the world, right? Oracle is the biggest. They own Oracle database and they also own MySQL, right? It means you can use MySQL without paying a dime, right? Did you pay when you were downloading? No, it is an open source, right? It means that it is free. It is free license. Also, if you want, you can change its source code to suit your needs. So you can reconfigure it even to suit your own what? To suit your need. Even though MySQL is an open source software, you can buy a commercial license version from Oracle to get premium support services, right? You can pay for some additional functionality, right, that is not present here. But this database is sufficient for whatever you want to use it for. MySQL is pretty easy to master. in comparison with other database software like Oracle database and Microsoft SQL Server, right? MySQL runs on various platforms such as Unix, Linux, and Windows. You can install it and all that, which we've done, right? So let us leave that. So basically, this is just the interface that we need to get used to and get accustomed to, right? So we'll understand and use this interface a lot more as we proceed. All right. So basically, what is a schema? Database schema. A database schema represents the logical configuration of all parts of all or part of relational database, right? Basically, let me explain this, right? A schema is a collection of database objects. A schema is what? Is a collection of database what? A collection of database objects, right? If you look at it, right? Let's go back to here. If you look at the HR schema, even if you look at the Avita, right? What it's telling is that in this database, we have tables, we have views, we have procedures, we have functions. All of these are objects that can be contained or that are contained inside the database. We have a database here that has information inside of it, right? Look at it. Inside the HR schema, I hope you can see my cursor, please. Right? Inside the HR schema, we have tables. Inside our tables, can you see all the tables that we have? Can you see all the tables that we have? These are all objects, right? So which means that this HR is a schema that has inside of it several types of objects. Some of them are tables, some of them are views. We'll talk about what views are later, right? This is a view, right? This is a view, right? We don't have stored procedures, we don't have functions. But in this database, we have two things. We have a table, and we have tables, and we have views. All inside what? Inside the HR schema. Are you following? So a schema is a collection of database objects. It can be tables. We'll talk about database objects as we proceed. Database objects, it can be tables, it can be views, it can be hyperlinks, it can be triggers, it can be procedures, it can be functions, it can be a whole lot of what? A whole lot of different objects, right? So a schema is usually made up of database objects such as what? Tables, views, constraints, indexes, synonyms and sequences, sequence, synonyms, database link, hyperlinks, and so on and so forth, right? You can have several objects inside a schema. So a database is usually made up of several schemas, right? We'll talk about all of that as we proceed. Any question as we close chapter 1? Any question? Any question as we close chapter 1 before we move into chapter 2? Any question? Chapter 2 is very short. Chapter 2 is very short. We will finish by, I promise you, by 9:30 we'll finish. By 9:30 we'll finish. Any question as we wrap up chapter 1? Any question? Any question? Please, I need the replies now. Any question? Raise up your hand if you have questions. Please, if you have questions, just ask the question directly. Go ahead, Mama.
Yes, please. Please, can you explain this schema again? I didn't quite get it very well. Please, thank you.
All right, thank you. All right, so when we talk about schema, let me use a very simple example. Right? We said a schema is a collection of database objects. Consider a schema a room in your house. In your room, what do you have? You have your bed, you have your mattress, you have your clothes, you have your shoes, you have your perfumes, you have your body creams, you have your books, you have your luggages, you have everything that is owned by you is in that room. And that is what a schema is. A schema is a collection of database objects. Your room, so a schema is like a logical space where a user puts all the objects that he has created. So take for example, if I, we say we all work in the same organization, I'm user Shew, I would create my own schema, right? Say I'm working on a database for MTN, right? Right? I will create my own schema, my own objects. You would create yours. Everybody will create yours. The collection of all these objects is what becomes a database. So think of a schema as a small database, right? Now, I don't want to use the word small because they can be very large, right? But schema is a collection of database objects, right? A schema is a logical space where we put different objects that are of the database, right? Inside of, right? So you have tables, views. Views are base tables, right? Views are they are windows of base tables. We'll talk about views much later. Constraints, primary key, foreign key, not null, unique, and check constraints, right? There are just 5 of them. Indexes, right? Bitmap and B-tree indexes, right? Sequences, right? Synonyms, aliases, database links, and so on and so forth. It can be anything. All of these objects. So if I create multiple of these objects, right, and I put them in a single location and I give it a name, that becomes a schema, right? So like I showed you earlier, right, this HR is everything that has to do with the database called HR, right? This is a schema, right? So you would see that sometimes we interchange the word schema with database. They mean the same thing because remember, a database is a collection of what? It's a collection of tables. In this schema now, we have a collection of tables, right? All these tables, right? These tables are the most important part of this schema. Every other thing are done or are related to the tables. We'll talk about that as we proceed. But every other object here are most likely related to these tables. So this is a database, as much as we call it a schema, right? So when you hear the word schema, think about your room. Think about a room that contains several objects that is owned by that user. Right? That is what. So you can create a database. I can create a database, which is a schema now, and call it, let's call it quickly. Let's call it Quincy. When I'll just be using your name anyhow. You have to be paying for advertisement, right? She's still in class, right? Can you see now? Can you see that I have Quincy now, right? As a schema, right? So if I'm the Quincy user, every object that I create will be stored inside this place. Hence, it becomes my database. Are you following? Does that make sense? Does that make sense?
Thank you.
Yes, ma'am. Queen, where are you? Oh, yeah, talk to me. Talk to me.
So I'm there.
You are raising up your hand now. I think you want to say something.
Nothing to say. I'm following.
Okay. All right. Awesome. Please don't just be silent. Madam Olakuju, are you there? Madam Udwak, are you there? Just talk to me. Let me hear your voice. Mr. Femi, talk to me.
Yes, I'm here.
Awesome. I hope you're following me back to back. Follow me. Awesome.
Yes, our friends.
Iceman, I did not say you should talk to me. I did not call you.
Just trying to call myself so that I won't sleep. Let me be calling
yourself. Call yourself.
Hey. Iceman, you get yes, sir.
All right. Awesome. Now let us go into chapter 2. Right. Chapter 2 is just introduction to SQL, right? Just an introduction class to SQL. Right? I think it's just 2 or 3 slides that I have there. Yeah, it's just 2 slides. So it's a straightforward slide, right? SQL, introduction to SQL. So we've been talking about SQL, right? Let's know what this SQL is. SQL is called structured query language, right? Some people call it SQL. Some people call it SQL. SEQUEL. Let me see if I can write that out. Some people call it SQL. SEQUEL. Right. So SQL or SQL, right? But I prefer SQL. SQL sounds somehow, right? SQL. It says is a domain specific language used in programming and designing, designed for managing data held in a relational database management system. What does that mean? Plenty story, right? SQL is a language that is used, a programming language that is used to manage or communicate with a structured database or with structured data. Remember we said that structured data are data that are stored in rows and columns, right? And when you store data in rows and columns, it means that those data are stored in tables. If the data are stored in tables, right, then we call them what? A relational object, right? If they are called relational objects, then they can what? You can connect with them or you can interface with them with SQL. Right? So SQL is meant for structured data. Structured data are relational in nature, right? So SQL so that's basically what SQL is for, right? It is particularly useful in handling what can you see? Handling structured data. Right? Structured data. That is data incorporating relations among what? Entities and variables, right? We've talked about that already. The present dialect of SQL. SQL is a language. It's like Yoruba, right? Or Igbo or Hausa, right? It's a language, right? And languages have dialects. They have, what are the dialects in Yoruba language now? Or your language? I don't know Yoruba, so I will probably, somebody help me out, right? I don't know Yoruba. I just know Yoruba. I know, but I know that Jebu people have their own dialects, right? Ondo people, yes. Ondo people also have their own dialects. Ekiti people, hey.
Oh, correct.
I think every state, I'm not sure. Every state probably has their own dialects, right? So when an Ijebu Yoruba man is talking to a Ondo Yoruba man, right? They probably are speaking the same Yoruba, but the dialect is a bit different, right? So it's the same thing that we have in SQL. SQL is on I think the present dialect is 2016. Yes, 2016. Let us confirm that so that we don't say SQL dialect. Okay. I'm coming. What's it sounding? All right. Looking for SQL dialects. Do this magic. Sorry. Just trying to confirm the dialect that we have. I think it's still 2016 dialect. I just want to be sure. Where's this, guys? Can you still hear me? Right? Okay, I'll confirm that as it, right? I'll confirm that. But I think it's still 2016 dialect, right? So we have the 2016 dialect. And usually when we talk about dialect in SQL, it means that when a new dialect comes in, you just had a few things, right? Just had a few things. but majorly it does not really affect the structure of the SQL language itself, right? It's just maybe add a few things. Most of the time, these things are not very, they are not very important, right? Or they don't cause major change in the language, right? There is no dialect in, you cannot do anything to the Yoruba dialect now that will cause a major change and will make us be speaking French or Yoruba, make Yoruba look like Spanish, right? So even if they do, the same thing with English language, right? Even if you make changes to English language, they are usually not totally transformative. It's the same way with SQL, right? SQL has a file extension of .SQL. So if you see any .SQL file, if you see a file that ends with .SQL, know that it's an SQL script. Basically, what is inside of that file is SQL statements, right? And you can open it with any SQL software, any DBMS. You can open a .SQL with any DBMS, right? SQL is efficient, easy to learn and use. SQL is very efficient. It's very easy to learn. It's very easy to use, right? You can see as I was writing SQL the other time, right? You don't need anybody to interpret it to you because it's basically simple. Select, from, join, using, where, right? You see that it's basically like English language, like I mentioned earlier, right? It's basically like English language. Now, SQL provides statement for variety of tasks, including querying data, right? We can use SQL to query data. That's basically what we're saying there. We can use SQL to query data. We can use SQL to query data. Right? We can use SQL to query data, right? Query data, we'll talk about that later because we have a language called data query language. We can use SQL to insert into a database, to update a value in the database, and to delete rows in a table, right? We can use SQL to insert, to update, and to delete. We can use SQL to create, to replace, to alter, and to drop objects on the database, right? So think of SQL as that language that you use to, if you want to ask, actually, when you send a statement on, when you ask a question on Google, right? When you ask a question on Google, what usually happens is that that question that you ask, an SQL statement is written for it, right? Automatically for you, right? Implicitly, right? Implicitly. It converts to an SQL statement and it goes into the database and it fetches results for you, right? Basically, that's so you discover that what you're doing every day when you use Google is that you're using SQL. You just don't know that you're the one, although you're not the one writing the SQL, right? The SQL statements are automatically generated from the keywords that you use in your search, right? Even though it is not directly SQL, but basically something like that, right? Right. So you have SQL, you can use SQL to query data, you can use SQL to insert. So take, for example, in your organization, you want to change somebody's salary from $7,000 to $10,000 per month, right? You use SQL to change that. If you're using a proper database, right? Use SQL to change that. Mr. Femi moves from, maybe he was promoted from being supervisor in a construction company to president of the construction company, right? What happens? It is with SQL that we will change his job ID and indicate that he has been promoted, right? So we use SQL to also what? To create objects, to replace objects, to alter objects, and to drop objects on the database, right? We use SQL to control access to the database and its objects, right? In the database, think of the database as your house, right? If you're in your house, nobody can just come into your house and say, Alaja, let me use your computer. Right, Alaja, where's your pot? I want to eat. I want to take soup. Right, Alaja, where's your bed? I want to sleep. I can't even come to your house and do that. Right, because why? Why? I do not have the permission. Right. So if you look at it, when your mechanic comes in or your housemaid comes into your house, or that woman that is not really welcome to your house, what do they use? They usually sit down with one bomb, right? And the reason is because they are not welcome. They are not totally welcome. They don't have access. Right, but you have that younger brother, you have that elder brother that once they come in to your house, the first place they're going to is your kitchen. You don't even need to serve them. They go and serve themselves. Reason why can they do that is because they have access. You have granted them access. If you have not granted them access, they will also know what past the sitting room. So there are some people that come to your house that cannot leave the sitting room, right? They can't go to your store. They can't go to your bedroom. But when your mom comes to the house or your dad comes to the house, you can easily enter into your bedroom, into your sitting room, or anywhere in the house. Because why? They have access. Some of your cousins can even come and just pick your car keys and say, I want to quickly buy something in front, and they go without, and that's because you have given them access. And the same thing that we do on the database, right? You control access. You cannot do anything on the database if you are not given access. I'll say that again. You cannot do anything. Anything. I mean, you cannot even log in into the database if you do not have access. You cannot log in into the database. Even though a user has been created for you, if you do not have access, you cannot use that user that has been created for that account that has been created for you. You cannot use it if you are not given access, right? And of course, we use SQL to guarantee database consistency and integrity. We use SQL to guarantee database consistency and integrity. You see that part? I'm going to explain a whole lot of consistency and integrity because it has to do with a whole lot of explanation, right? We'll explain that much later. To wrap up today's class, right? To wrap up this interesting class, we've had over 2 hours of class today, right? We just want to look at the type of SQL statements and what they entail, right? We'll also be starting from here next class so that you don't, right? Can you see chapter 3 straight? We're moving to chapter 3 directly, right? So, type of SQL statements, right? We have the first one is called the data query language, right? Before now, SQL used to be 4 parts. SQL used to be 4 parts. This select statement used to be part of data manipulation language, but it has in the new dialect, which is 2016 dialect, it was what separated out, right? Nothing changed except that it was separated out of data manipulation language. So we now have what we call the DQL, the data query language. It says statements. These DQL statements are used to perform queries on the data within database schema, right? You see this select statement, right? Select statement is what we use in data query language. It is the most important of the SQL statements to data analyst. That is what you will be writing most of the time. SQL select statement. You just be using select statement to fetch data that you want to analyze from the database. It's as simple, right? So it's a very, very important statement for us, right? We use it to pass queries to the database and to get results from the queries will fetch results from the database, right? The next one is the data manipulation language, which is to what? To manipulate data. We use them to manipulate data in the database, right? We use the DML to manipulate data in the database. And there are 3 of them. We have the insert statement, which is used to insert tables, insert data into a table. We have the update, which is used to what? Update or change values, existing values in a table. And we have the delete, which is used to delete records from the table, right? You see that they are English language. Think of them as English, right? We have the what? We have the next one, which is the data definition language. The data definition language consists of SQL commands that are used to define the structure or define the database schema, right? We'll talk about them much later, right? We have the create, which is used to create the database and its objects. We have the drop, which is used to delete objects from the what? From the database. Create, to create, drop, to delete. Alter is used to what? To alter the structure of the database, right? Already something that has been created already, you can alter it. Truncate is used to remove records from a table, including all spaces allocated to records are removed, right? We'll talk about truncate. Comment is used to what? To add comments to the data dictionary. And rename is used to what? To rename, to give a new name to an object existing in database, right? Then we have the next one, which is the data control language. Remember, I said that you cannot do anything on the database without what? You giving what? You've been given what? Permissions given to you, right? How do we grant permissions in the database? We use the word grant. We use the statement grant. It's a data control language, grant. So I grant you permission. If I want to take away that permission from you, English word, revoke. So we use what? We use the revoke command. You see, I told you that what? You already know SQL because you know English language, right? So you grant, you revoke, right? To create, you use create. To drop, you use drop. To delete an object, you use drop, right? To alter, still alter, right? So you see, it's English language. And the last one is the transaction control language. We have the commit statement, right? in SQL, in Excel, in in Excel, in Microsoft Word and all that, when you are done with a document, what do? You save it, right? Save, right? In SQL, we commit it. So commit actually means save, or save means commit, right? Rollback is to what? Is to undo. Remember, I used to do, you press Ctrl Z. If you make a mistake, you say, yeah, press Ctrl Z to undo it, right? That is rollback. Rollback is to undo, right? To undo changes or errors that have occurred, right? And the last one is save point. Save point is used to guarantee read consistency and read consistency and accuracy. We'll talk about save points much later, right? So this has brought us to the end of our first week in SQL, right? So next week, starting from next week, we would pick them one after the other, these languages. But in most classes of SQL, they usually start with the DML. No, they usually start with the DQL. Then they move to DML, then they move to DDL, and so on and so forth. But I am not doing that. I sat down and I thought about it, and I said, the best way to do SQL is to start with the data definition language, right? Start with data definition language, then from there we'll move to the data manipulation language, and from there we'll move towards to every other part of SQL. So starting from next class, that's next Friday, we'll start with what? With the data definition language, where you will learn how to what? How to create tables, how to drop tables, how to create constraints, how to alter, how to drop, and all of that, right? You learn all of that from next class. I will drop this. This slide is not complete yet, right? I will drop this version that I have with you that covers everything that we've done so far, so that you can have something to read, right? The assignment for the week will be dropped on the WhatsApp group, right? Is a research assignment, all right? I have an article that I also want you to read. I'll drop some of those articles for you to read as well, right? And possibly as well, I will drop an SQL Bible. You're thinking about it, I'll drop an SQL Bible that you can always refer to anytime you have issues with SQL. That is beyond the class. You can use this forever. You can use this when you're at work or when you are involved on a project or something, right? You can always reference this Bible anytime you feel stuck or you want more explanation on something. So we've come to the end of today's class. Any question, please ask me your questions now. Any observations? Tell me about today's class. Was it better than yesterday's class? Did you learn something? Was it insightful? Was it worth your time? Was it worth sacrificing your 1 hour of sleep? Please let me know.
Today was better than yesterday's class.
Yeah, very much better than yesterday. Yeah. And very fast. No, we enjoyed the class actually.
Awesome.
Today was better than yesterday because I was unable to comment and do all those stuff.
Awesome.
So
Today
I
is
enjoyed
better
it than yesterday.
Today is a great class, sir. We really
as in
awesome.
today na bomb. Today is better, big.
Awesome.
very, very
I'm glad we enjoyed it. I'm glad we enjoyed it. All right. Any question?
Better than yesterday.
Awesome. Thank you, ma. Any questions?
Just help us drop the slides for this class.
I will.
That was can just treat it.
I will. Sammy, any questions?
Some of us are not good in jotting down. We are lazy.
Right. Lazy students. Sammy, talk to me. Madam Udwak, talk to me.
Today was better than yesterday. Very
Awesome.
interesting. At least I wasn't sleeping.
I told you will not sleep in my class. No, you will not sleep. No.
Thank you.
You will not sleep in your class. Awesome. Queen, my personal person, talk to me.
You have said it all.
Yeah. You want to sleep. I can hear sleep in your voice.
Not really.
Awesome. Mr. Femi. Mr. Femi,
yes, sir.
Talk to me.
Yes, sir. I mean, the class is very informative, so I mean, it's good. Yeah.
Awesome. Awesome. Thank you. Madam Olakoju, talk to me. Ebuka. Madam Olakoju, did you learn anything new? I know you have done SQL before. Did you learn anything new?
Yes, I did. I'm surprised you could bring data modeling to SQL. I thought it was just done in Power BI.
Nah. SQL actually owns data modeling. Every other person borrowed it from SQL.
I only learned it in Power BI. I didn't know.
Yeah,
I was surprised actually.
A lot of people skip it actually, right? Because it has to do with constraints, learning constraints, and learning constraint has given a lot of people plenty problem, right? But don't worry, in this class you will learn how to use constraints and be able to create data model in SQL because it's easier. Okay, talk to me.
I also learned SQL before, but in fact, it's a tug of war for me. But now that you are explaining, I can get it right.
Yeah, that is my job. That is why you are here.
Thank you.
Awesome. Thank you so much. I don't want to take much of our time. Please engage the classroom, engage our. Okay, Mr. Fem, talk to me.
Yes, I remembered I told you about me. I told you about Fridays.
Yes,
I said
your Fridays. Yes.
Fridays, yeah. So I don't know if there is a provision for me, to take the classes or class some other days,
Oh, okay. Well, like I said, you and I would have to talk about that and have one-on-one on that so that we can create a separate arrangement. Right. So let's do that. Right. Maybe once you are done, once we finish the class, you can just chat me up so that we can have that discussion.
Okay. All right. Thank you.
All right. Thank you everyone for coming. Please engage the class. The group is not just for marking present or for us to. Please engage. If you have questions, I don't have to be the only one to answer your questions. You can easily drop questions on the group so that everybody can engage. And if we now get to a level where nobody is able to answer or we need more clarity, then I can always come in to answer the question. That's the way to learn, right? This is your community. This is your community to learn. So please, if you have questions, if you read something that you do not understand, or you just want to help the class, right? Drop questions, drop materials, drop things that would help the class proceed and help the class learn. Alaja, talk to me.
So are we going to have the record of this, the audio record?
Yes. Yes, it's a video record. Yes, you would have the class is recorded. You get the link very soon, right? You'll get the links to both classes. I'm hoping I can do some editing to it, right? But you get the link to them very soon, right? Hopefully by during the week you get the link to them.
Okay.
Madam Ola, could you talk to me, please?
Okay, so Mr. Sean, please, is there a way you can enable the chat session so this chat so that we can chat? Because sometimes you just don't want to interview with the class.
I get you. Challenge with the class with the chat is that Microsoft wants me to pay to use that feature, and the dollar that they are calling. First of all, my account is paid, but I think what happened yesterday that I could not share was because my account was suspended for. Of course, we can't pay $2 and all of that. We can't subscribe to some of these things. So I think that was one of the things that affected it. I just had to find a way around it to be able to present and you'll be able to see my screen today. So I think that's one of the challenges that we have with the class, with the chat function, right? But that's why you can use the WhatsApp group, right, for chats. You can use the WhatsApp group for chat. That's why if you look at it, I've been interfacing with the WhatsApp group so that I can see if there's questions in the WhatsApp group that I want to attend to. So please, I apologize for that. But let us use, if I can find a solution during the week, I will do that. But if not, let's just use WhatsApp as our communication channel. Any other question? Any other contribution? It is 9:33 already. What do you say, man?
I said noted. Thank you.
All right. All right. All right. If there is no question, no contribution, thank you for coming. Do have a wonderful night. God bless you. Peace to the Middle East, peace to Sudan, peace to Ukraine and Russia. God bless you. Peace to every one of you. Thank you for trusting me. Thank you for attending class. It's a thing of joy to see everybody here. All right. God bless you. Do have a wonderful night.
You're so amazing.
Bye.
Bye. Yeah, Queen, I know you want to go and say bye. Bye.
Bye.
Good night, everyone.
Thank you. Thank you for the class.
Bye. Enjoy your
Madam Angela, good night.
Thanks for today.
Good.
All right, thanks for today, Mr.
Good
Show.
night.
Appreciate it.
Thank you, sir.
Thank you so much. Thank you so much. Thank you, man.
Thank you.
Thank you. Do have a wonderful night.
Bye. You too. Good weekend as well.
Thank
Bye.
you so much. Thank you. Bye.
So